Okay, students, Assalamu alaikum. Let's start our today's lecture. So, we are already done with chapter number 12, 13, 14, and 15. So, four chapters are done. And actually, in the four chapters that we have already done, we have already gone through them. These four chapter completes the entire dynamics study for the case of particles. So, all the laws of dynamics which were needed to study the dynamics for particles are already done. Now these laws are not going to change. They are going to remain the same. The only thing that's going to change is that now we are going to study the dynamics of rigid bodies. Now what's the difference between rigid body and particle? I discussed it in the very first lecture. Particle is something which is like a dot. It has no shape, no size. So the rotation factor of the particle is ignored. Now previously we were discussing about particles, so there was no rotation factor. Now we are discussing the rigid bodies. The rigid body is something which has a specific shape, which occupies a specific volume, and which so now something that has a specific shape and occupies specific volume, that means now that thing can rotate as well. So the rotation factor of the rigid body is something which is now going to be taken into consideration as well. All the laws that you studied in chapter number 12, 13, 14, and 15, all those laws are equally applicable. None of the law is invalid. All the laws are equally applicable, but now the complexity of the problem will become more enhanced, or the problem will become more complex, because now you are also going to consider the rotation factor of the of the rigid bodies as well. Previously we were talking about particles, so there was no rigid body. Okay, so the study methodology would remain exactly the same as you went through in case of the study of dynamics of particles. In chapter number 12 we studied kinematics of particles. In chapter number 16 we are going to study kinematics of rigid bodies. In chapter number 13 we studied the force and acceleration method for kinetic of particles. In chapter number 17, we are going to study the force and acceleration method, which will be the kinetics for the case of rigid bodies. In chapter number 14, we study work energy principle. In chapter number 18, again, we are going to study work energy principle, but for the case of rigid bodies. Similarly, chapter number 19, we're going to study the impulse momentum analysis for the case of rigid bodies. So 12, 13, 14, 15, exactly the same way we will have 16, 17, 18, 19. Okay, the only difference is that previously we were discussing about particles, so it has no shape, no size, and there was no concept of rotation of particle. But now we're going to have rigid bodies. So rigid body will have shape, they will have a specific size, and they might rotate. The rotation factor will also be taken into consideration. So all the laws which you studied from chapter number 12, 13, 14, 15, all laws are equally applicable here as well in chapter number 16, 17, 18, 19. But some additional things will be added to it. Do you understand the procedure, or the point where we stand right now, and what we are going to what we are going to continue from here onward? Okay. Chapter number 16. So we're going to discuss about the rigid body motion, translation, rotation, absolute motion analysis, relative motion analysis. Let's discuss about the type of rigid body planar motion. We can have translation, we can have rotation about fixed axis, we can have general plane motion. Translation means moving from one point to another point. Okay, so we can have rectilinear translation. If the motion is in a straight line, if the motion is in a straight line, then that is rectilinear translation. If the motion is in a curved path, okay, if it is a curved path, then we call it curvilinear translation. Okay, So curved path means curvilinear translation, and straight path means rectilinear translation. Rotation about fixed axis. All particles of the body move along a circular path except those which lie on the axis of rotation. So rotation, we understand that. Okay, what is rotation? Okay, now before moving forward, okay, let's discuss about this general plane motion as well. What is general plane motion? General plane motion is a motion where you have rotation as well as translation both together. So here the body is moving in a curvilinear translation while at the same time the body is rotating. So if both the things are there, then we call it a general plane motion. Now here is a question about it first, that what is the difference between curvilinear translation and rotation? Okay, so let's try to let me explain this from a concept here. We know that Earth is rotating around Sun. We know that Earth is rotating around Sun. We also know that the Earth is spinning on its own axis. Okay, so the Earth is spinning on its own axis. In strictly engineering terms, when we talk about the rotation of Earth around the Sun, we don't call it rotation. Okay, we call it that the Earth is in a curvilinear motion, curvilinear translation around Sun. For the rotation, important point is that the axis of rotation should pass through the body itself. So for example, if this is the body, for example, if this is the body, let's say this is the body, then the axis of rotation should pass through the body. So suppose if the axis of rotation is this and the body is rotating like this, then the axis of rotation is passing through the body, so we say that this is rotation. But suppose if the axis of rotation is not passing through the body, suppose this is the body and the axis of rotation is here, okay, and the body is revolving around the axis of rotation like this. Okay, so in that case, now we don't call it as rotation, but rather we call it as curvilinear translation. So this is a journal difference. So in reality, when we say that the Earth is rotating or moving around the Sun, so we don't call it that the Earth is rotating around the Sun. We say that the Earth is in a curvilinear translation around the Sun. But when the Earth is spinning on its own axis, so the spinning of the Earth on its own axis is actually the rotation of the Earth. So that's the general difference between the rotation and curvilinear translation. For the case of rotation, the axis of rotation must pass through the body. Okay, whether the axis of rotation is here or here or here or here, but it must pass through the body at one point from the body. Okay, but if the axis of rotation is not passing through the body but somewhere else, then we don't call it that the body is in rotation, rather we call it the body is in a curvilinear translation. Okay. Here, for example, we have here, this is a kind of an assembly. So suppose if this thing suppose if this thing moves in this direction, so what will happen? This will be pure rotation. This will be pure rotation, and this pure rotation will cause this rod or this member to move in a curvilinear translation like this. As a result, this wheel will move and the wheel will be in a pure rotation motion. Okay, and this will cause this piston to move in a rectilinear translation motion, while this member will be moving in a general plane motion because it will be rotating as well as it will be translating. Again, we show all of these things to you here, but you did not see the motion itself. The motion, you have to visualize it in your own mind. This is the problem with the course, that there is motion everywhere and you're studying the motion, but you cannot see the motion because you're studying everything on paper. how the second column will rotate. This column, this member, it will be, look, when this is going to move like this is going to move like this will move like this. Okay, so the position of it will become like this. Let's say like from here, okay, to here. Okay, so it has moved. So this is translation, but at the same time its angle has changed. Previously the angle was this, now the angle is this. The angle has changed a little. So when the angle is changed, that means there is rotation, and when it has moved from one point to another point, this is translation. Again, this is something you need to have visualization. You need to have an understanding of how the thing is going to behave in motion. I cannot really show you the visualization. I can just try to explain things, but you have to visualize it in your own mind, how the motion is going to be. And this is the problem with this course. If you cannot visualize, then it will not be easy for you to understand the problem. Okay, so what we say is that suppose I have a body here, and there are 2 points within the body. Okay, so the position of the 2 points of the bodies can be related. Okay, and the relationship is rb equals to ra plus rba. Okay, so if this body is going to move, suppose if this body moves or translates, we call it if the body translate from one point to another point. Okay, so because of the translation, what we say is that rb and ra will move. Okay, but if there is no rotation, then rb by a will be zero. This component will define the rotation. Okay, so if there is rotation, then this term will not be zero and b will be rotating with respect to a. But if this term is zero, that means rb and ra are same, and that means the body will not rotate. So this is how we define in terms of translation. Okay, this was the summary of chapter number 12. If you remember, these were the formulas that you studied in chapter number 12. We had uh, we had this position vector, displacement vector, differential of displacement with respect to time, that's velocity. Double differential, it will of displacement was acceleration. Okay, then we had this equation for constant acceleration. We have this equation, another equation, third equation. We developed all these equations in chapter number 12. Okay, then we also have this equation ADS is equals to VdV. So all these equations which you see on this page are the ones which we actually developed in chapter number 12. And all of these are equally valid in this chapter as well. Okay, so we don't need to develop these equations again and again. We have developed in chapter number 12. That was for the case of particles, and even for the case of rigid body, they are applicable. So now let's discuss about the rotation. How do we define rotation? For rotation, we need to define angular position. Like for example, here we had the linear position. S was basically what? The displacement, but it was the linear position. Now, for the case of rotation, we have to define angular position, and angular position is defined by theta. Okay, so defined by angle theta, which is measured between a fixed reference line and are measured in radians. Okay, so angular displacement will be d theta, like we had ds. So ds, so here we will have d theta. So okay, and what is the relationship? One revolution is 2 pi radian. This is a general relationship for angular displacement. So one revolution is 2 pi radian, which is equals to 360 degrees which is equals to 360 degrees. Okay, so like we had velocity, so since we have angular displacement, so if we differentiate with respect to time, we'll have angular velocity. So d theta by dt will give you omega. Omega is basically what? It's velocity, but the angular velocity. We call it omega. Then we can have, like we had acceleration, we can have angular acceleration. So angular acceleration will be alpha. Alpha is what? D omega by dt. So it will be theta double dot. Okay. Like we had a relationship ADS is equals to VdV, we can have also relationship in the angular format as alpha d theta equals to omega d omega. Like we had equations for the linear acceleration, for constant linear accelerations, we had three equations we developed in chapter number 12. V equals to V naught plus ACT. So in the angular format, for angular format, it will be omega equals to omega naught plus ACT, alpha CT. Similarly, second equation and third equation. So these are just the comparison of the equations which you studied in chapter number 12. These are for the linear case and these are for the angular case. And if you see there, the only difference is that S is replaced by theta. Wherever you have velocity, it is replaced by omega. Wherever you had acceleration, that is replaced by alpha. Otherwise, these equations, these set of equations are exactly the same as this set of equations. Before moving forward, is it clear so far till here or not? Okay. Now these angular terms, these are the linear terms, let me call them L, and these are the angular terms, let me call them A. These linear and angular terms can be linked together. We can have an equation which can link L with A, or all the linear equations or the linear terms with the angular terms. Okay, and what is this relationship? Let's discuss that relationship. Exactly, this is by R. Okay, so for example, when we have when we talk about the angular position and the linear position, angular displacement, linear displacement, so S is equals to R theta. This is the relationship which is relating linear quantity with the angular quantity. Okay, then similarly, since we have velocity is ds by dt, but we know that s is equals to r theta, we can substitute r theta here. So it becomes r d theta by dt, but d theta by dt is omega. So it becomes v equals to r omega. So v equals to r omega becomes another equation. Okay, so here this is the linear term, this is the angular term, and we are relating linear with the angular using this relationship. Similarly here, AT is dV by dt, which is equals to d by dt, but v equals to r omega. So just substitute v equals to r omega. R is going to come out, so d omega by dt, which becomes r alpha. Okay, so so it becomes like this. So tangential acceleration is basically equals to r alpha. So we can relate acceleration with the tangential acceleration, angular acceleration. This is angular, this is linear. In the linear format, we also have the normal acceleration. Normal acceleration is v square upon r, or it becomes omega r whole square upon r, or it becomes omega square r. So that's the relationship between the angular terms, sorry, the linear term with the angular term. Okay. If we can find out the overall acceleration is tangential acceleration square plus the tangential acceleration square plus radial, or the normal acceleration square under root. So just substitute the values and you'll get this equation for the overall acceleration. Okay, let's give a break of 2 3 minutes for the azan to finish, and then we are going to start again. Okay, now we can have two bodies. They can be linked together. Their motions can be linked together. Always remember one thing, that suppose if we have two bodies, their point of contact will have the same linear velocities. So suppose if I have two gears here, let's say this is one gear and this is another gear. This gear could have a different velocity with this gear, but the point of contact of the two gears will have the same velocity. So if they have the same velocity, then the linear quantities can be linked for the two objects using that same point of contact. So it should be S is equals to R1 theta 1 equals to R2 theta 2. Similarly, angular linear velocity can be linked in such a way that since at this point the velocity is the same, so it's R1 omega 1 will be equal to R2 omega 2. Similarly, at this point the acceleration is also same, so R1 alpha 1 will be equal to R2 alpha 2. This is the same for the case of gears. Suppose these are the three gears in connection, so the point of contacts will have the same values, or at least same linear values. This is true for the case of direct contacting gears, or we have the perpendicular gears like this. So again, they have the same values at the point of contact. And similarly, this is also true for the case of the pulley and rope arrangement. So suppose you have two pulleys, okay, and they are connected with a belt, or you can say the belt and pulley arrangements, and the two pulleys are attached together or connected together with the belt. So because the belt has the same speed, so whatever the velocity of the linear velocity of the belt here will be the same as the linear velocity of the belt here. So theta is the angular displacement. Okay, so body is rotating. So theta is the angular displacement. So theta 1, let's say this is body 1, so that will be theta 1. And let's say this is body 2, and it will be rotating like this. So it will be, let's say this will be theta 2. Okay. So thetas are the angular motion of the bodies here, and the point of contact will have a linear motion. Okay. So that is, things will be much more clear when we are going to start solving the problem. Okay, so let's see the class. One problem here. A motor gives gear A an angular acceleration of alpha A equals to 4t cube. So this is the gear A, and this gear A is having an acceleration given by the motor. How much it is? It is 4t power 4t cube, where t is in seconds. If this gear is initially turning at angular velocity of 20 radian per second, so initial velocity is given. Determine the angular velocity of the gear B when t equals to 2 seconds. So we need to find the angular velocity of gear B when t is equals to 2 seconds. So we know what is the initial velocity of gear A. We need to know what will be the final velocity of gear B when t equals to 2 seconds. Now for both the gears, the radius of the two gears are given. So let's see how do we solve this problem. So this is the case we have. We have alpha A is equals to 40 cube. We have omega A initial given, which is 20 radian per second, and omega B we need to find at 2 seconds. Okay. So the thing is that we can find what is omega B at 2 second if we know what is omega A at 2 second. But we can find omega A at 2 second if we know what is the relationship of omega B with respect to time, omega A with respect to time. Okay. So this is the idea. So first we are going to do this thing. We know that alpha A is equals to d omega A by dt. Okay, but alpha A is given as a function of time, so we can just substitute alpha A as a function of time. So if you put alpha as a function of time, then we can integrate it and find out what will be omega A as a function of time. So if you integrate it, it will become like 4 t power 4 by 4. 4 will cancel, so t power 4, 0 to t. So initial omega A we already know, so it will be omega equals to t power 4 plus 20. Now we know what is omega A as a function of time. Once we know omega A as a function of time, now we can relate the omega A and omega B, because we know that the two gears are in contact with each other. So the velocity of the contacting point of the two gears would be same. So VA will be equals to VB, which means omega A RA will be equal to omega B RB. Okay, so that means we can find what is omega B at 2, since we know what is omega A at 2, and since we know what are the radiuses for RA and RB. So just substituting the values of radiuses, we'll get what is the omega B at time t equals to 2 seconds. This was a simple problem. Before moving forward, I need to know, do you understand how we went through this problem? You're going to be a little confused at this moment because you were comfortable looking at S, V, and A as displacement, velocity, and acceleration. Now you're not looking at S, V, and A, rather you are looking at theta, omega, and alpha. The same equations are being used, but in the angular format. So once again, No problem. I can repeat the problem solution again. But is there anything in the solution of the problem that you do not understand? Okay. The thing is that how do we start to solve? First of all, we need to know that what do we need to find? We need to find what is omega b. Okay. We need to find what is omega b when t equals to 2 seconds. When at 2 seconds. 2 seconds. Okay. First of all, do you understand that what is asked? Find omega b when t equals to 2 seconds. Okay. The next thing is that we can find it if we know what is omega a when it is at 2 seconds. Okay, because we can relate the omegas of a and b together by the relationship omega ra omega a equals to rb omega b. Okay, so we can find this if we know what is the omega a at 2 seconds. For omega a, we know what is the initial omega. I mean, what is the initial velocity? Okay, but we don't know that what will be the final velocities in 2 seconds. So, but first, what we need to know is what is the relationship of omega with time. It's like finding what is the relationship of velocity with time. Okay, so previously we used to do it like this: that we know a equals to dv by dt. Now, if a was given as a function of time, then we can find what is v as a function of time. This time only the difference is that it's not a, it's alpha, and it's not v, it's omega. So we know alpha is a function of time. We just substitute it. We'll find what is omega as a function of time. Then we can find at 2 seconds what is omega a at 2 seconds. Once we know that, then we can relate the two gears and we can find what is the omega of b at 2 seconds. Is it clear? Is there any step within the solution of this problem which is not clear? Please ask. So their alpha is equal. Sorry, what did you ask? What did you say? So their alpha is equal. I couldn't understand your question. If you're not able to ask it by writing, you can just open the mic and you can ask it directly. It will be easier for me to understand. Omega times the r. Yeah, omega times r is basically what? It is the velocity. Okay. So velocity is basically what? V is r omega. So what we are saying is that since the two gears are in contact with each other, the point of contact will have the same velocity. So VA will be equals to VB. So that means RA omega A will be RB omega B. Is it clear, Shahad? Okay. Is there anyone else who want to understand anything or something is not clear so far? You can ask. Okay, so there is next problem. You go through it yourself. It's a practice problem. There is self-study problem. You can go through it yourself. Let's come to the absolute motion analysis. Absolute motion analysis is basically what sometimes what happen is that the two or three bodies are linked together, okay, and uh, the motion of one body is affecting the motion of the other body. Okay, so whenever we have, like for example, in the case of chapter number 12, you studied the dependent motion, right? So the only possibility was there that when the bodies are linked together with rope, then they were dependent motion. So if there are two things which are connected together with rope, so it was like this, let's say body A and body B, and they are connected with rope. So if I move body A, automatically body B will move. Or if I move body B, automatically body A will move. This is what you studied in chapter number 12. That was dependent motion. Now here, the dependent motion is of a different type. Okay. What type of dependent motion we have here? Because now we have here rigid bodies. We are not talking about particles. We are talking about rigid bodies. Since we have rigid bodies and rigid bodies have a specific shape and size, so you can have the rigid bodies connected together with each other. So for example, here this is one rigid member, and this is connected with another rigid member. This is connected with a third rigid member. Okay, so there is a piston and a rod and another rod. So if the piston is going to move, it will going to cause the motion in this rod, which is going to cause a motion in this rod. Similarly, if this rod is going to rotate, it will cause a motion in this rod and will cause a motion in this piston. So all the three motions are actually connected with each other, or all the three motions are dependent over each other. Motion of one will cause the motion of the other. This is exactly the same way you studied in chapter number 12, but that was for the case when you have particles. So that was the dependent motion. The dependent motion which you studied in chapter number 12. The similar thing you are going to study here in chapter number 16. But now we are not talking about particles. We are talking about rigid bodies. So there are possibilities that rigid bodies are connected towards each other, together with each other, and the motion of one will cause the motion in the other. So let's study the problem related to that. Okay, so we have a crankshaft AB. Let's say this AB is known as crankshaft. AB, this is a member, is rotating at a constant angular velocity omega equals to 150 radian per second. So that's the motion. Constant angular velocity. How much? 150 radian per second. Determine the velocity of the piston P. Now we need to know what is the velocity of the piston P. We need to know what is Vp. At an instant when theta equals to 30 degree. So we need to find it when theta equals to 30 degree. So one thing is very clear, that when this crankshaft AB is going to rotate, it's going to make the motion of the piston, because they are all connected together and they are the dependent motion. So now we need to know that if this thing moves with a velocity with an angular velocity of 150 radian per second, then what will be the velocity of this piston? So previously you used to develop relationship like VA and VB, relationship between two bodies, or accelerate, or AA and AB in the dependent motion. Now we are making a relationship between the angular velocity of this crankshaft AB with the velocity of this piston VP. So this is a kind of a dependent motion. Before moving towards the solution of the problem, first of all, do you understand the problem statement or not? Okay, so now let's see the solution. Okay, the thing is that uh, we are given that omega AB is 150 radian per second. Now we need to find Vp when theta is 30 degree. Velocity of point P when theta is 30 degree. So we need to know that what is the relationship of Vt with Vp with theta, velocity of the piston with theta. Okay, so first we need to develop that, but before that we need to know that what is the relationship of xp with theta. Okay, so for that let's define x. Okay, so let's say that our total x is x1 plus x2. Okay, so this is the horizontal distance. Total distance is x, and let's say this is x1, this is x2. And so x1 will be what? X1 will be, since we know that this member can rotate, so we know that this member can rotate, and so the length here is 0.2, and theta here is theta. So I can say that x1 is 0.2 cos theta. Okay, And what will be x2? Now x2 I also need in terms of theta, okay, because I need the position in terms of theta internally. So x1 I got in terms of theta. Now x2 I also need in terms of this theta. So how can I do that? The methodology would be that, look, if this is zero point 0.2 cos theta, if this is this, then what will be this vertical height? This vertical height will be zero point 0.2 sine theta. Okay, so it could be zero point 0.2 sine theta. Now if we say this is zero point 0.2 sine theta and this is 0.75, then we can use the Pythagoras theorem to find out what is x2. So x2 will be 0.75 square minus zero point 0.2 sine theta square whole in the root. Okay, so now I've got x as a function of theta. This x was the position of the piston. This x was the position of the piston from A. So now I know what is x as a function of theta. So I can differentiate this x with respect to time to get the velocity with in terms of theta. And then once I have the velocity in terms of the theta, so now in the question it is given that when theta is 30 degree, find out what is the velocity of the piston. So you need to find out what is the velocity of the piston. The only thing that you need to do is then just substitute the values of theta and the omega which are given. So omega AB is given 150 radian per second when theta is 30 degree. Okay, now the difficult part in it in this question is actually the differentiation. So if you want to differentiate this term with respect to time, so it will be 0.2 negative cos theta will become negative sine theta into theta dot plus half this whole term power minus half. Then you have to differentiate this separately. It becomes negative 0.2 negative 2 into 0.2 sine theta, because here the theta term is here with square. Then you have to differentiate this internal term separately. It becomes zero point 0.2 cos theta theta dot. So you got this big term. Then it could be simplified it into this format. So wherever you have theta dot, it's actually omega. You already know the value of omega. Where you have theta, it's you already know what is theta. Just substitute the values, you will get what is Vp. So this was the solution of the problem. Before moving forward, do you understand how did we solve this problem? Is there anything within the problem that you do not understand? Remember, here what was asked is that we wanted to find out the velocity of piston for when theta is 30 degrees. So we need to know that what is the relationship of velocity of the piston with theta. That's why we need an expression for v as a function of theta. So we develop an expression for v as a function of theta. So first we develop an expression for x as a function of theta. And then after that, we just differentiate that function to get the velocity function of v with respect to theta. And once you have v with respect to theta, then just substitute the values to get the answer. Yes. You are absolutely right. It is clear, but it is hard to know how to think. And I think this is not just here, it is the whole course. The whole course of dynamics is like that, that sometimes things are not that difficult, but to understand the scenario and to understand and to find out the right procedure to solve the question, that becomes a quite more difficult thing. But the point here is that do you understand the solution procedure, what is mentioned here in this question or not? Is there anything which is not clear? Is everything clear in the solution procedure or not? By the way, this is my own handwriting solution. I'm sorry for very bad handwriting because I did it in quite a hurry. So anyways, let's move over to the next problem. This is a practice problem for you, and there is a self-study problem for you. Okay, so now let's study the relative motion analysis in terms of the velocity. The most important equation for us in this case, when we are going to study the relative motion analysis in terms of the velocity, will be this. VB equals to VA plus omega into RBA. VB equals to VA plus omega. Remember, this is a cross product. This X is basically a cross product. Okay. So omega cross RBA. Omega is the angular velocity of the body. Okay. So what does it mean? Suppose if I have a body here, and let's say this body is AB. Now it's not a particle, it's a body. That's why I'm writing AB. One part A, one part B. And this is the complete body. And suppose this body is in is rotating with an angular velocity omega, then linear velocity of point B is linked with the linear velocity of point A based upon what is the angular velocity of this body and this vector RBA. The vector RBA is basically what? Relative position vector drawn from A to B. So RBA means the arrow is at B starting from A. Okay, so this is RBA. The arrow is at B starting from A. So this is the general format of the equation. VB equals to VA plus omega RBA. Suppose if I want to write this equation in the other format, then it will be like this. VA equals to VB plus omega cross RAB. This is correct. This is correct. They both are same actually. But if somebody write like this, VA equals to VB plus omega RBA. This is wrong. This is correct. This is correct. This is wrong. Why? Because it's always in this format. VA equals to VB plus omega into R. It should be AB because first it is A, then B, then it should be first A and B. So this is correct. VA equals to VB plus omega RAB. VB equals to VA plus omega RBA. So this is correct, but this is wrong because it's AB, it should be AB, not BA. Okay, do you understand this equation? This will be the main equation for you to solve the next problem. Okay, this will be the main equation. And this equation is for one solid body which is in general plane motion. Okay, and what we are doing is that we are relating the 2 points of the bodies, the motion of the 2 points of the bodies, A and B. So VB equals to VA plus omega into RBS. Suppose if the body is not in motion, is not rotating. Suppose if the body is not rotating, then the omega will be 0. And omega will be 0, that means VB equals to VA. Okay, how there is two velocity in one body? Okay, let's say that if this is my body, suppose this is point B, suppose this is point A, it's possible that I make the body move like this, then there will be velocity of point B as well, there will be velocity of point A as well, right? So the two different points of the bodies both will have the velocities. Okay, and if the whole body is moving in the same speed, then the velocity at point A and B will be the same. But suppose velocity at point A is more than the velocity at point B, what will happen then? Then the body will become like this. So that means it will start rotating. So is it clear? Remember, so v when we discuss here vb equals to va plus omega rba, so this omega into rba is the term which determines the rotation factor. So this is the rotation factor. So let us consider this case. Determine the velocity of the block at an instant when theta is 60 degree. So the thing is that, look here, there is one member here, AB. This is one rigid body, AB. This rigid body is connected with another rigid body, BC. And this BC rigid body is connected with this piston at C. Okay. So there are three bodies in connection with each other. Okay. Now we know about AB because AB is pin connected at A, so it can only rotate. So there can be only rotation of AB possible. This body C or the piston C is in a specific path, is in a specific enclosure that it can only translate. So there can be only translation of C, there can be only rotation of AB. However, CB will go through general plane motion. It will go through translation as well as it will go through rotation. Before moving forward, does the problem statement clear to you or not? Determine the velocity of the block at an instant when theta is 60 degree. So when theta is 60 degree, we need to determine what is the velocity of this block. If the link AB is rotating at 4 radian per second, so this is the rotation of the link AB. Before moving towards the solution of the problem, first of all, is the problem statement clear or not? Okay, so let's move towards the solution. So we need to know that what is the velocity of C. C is the block piston when theta is 60 degree. Omega AB is given as 4 radian per second. Okay. Now, what we need to do is that we need to determine what is the velocity at C. Okay, we need to determine what is the velocity at C. Since we need to determine what is the velocity at C, so the idea is that we need to look at this link BC, because the C is the point of contact of the link BC with the piston, with the block. So if I know that what is the velocity of point C in the link CB, that would be the same velocity of the block. Okay, whatever is the velocity of the point C in the link BC, that would be the same velocity of the block. Okay, but the link BC is in the general plane motion. So since it is in general plane motion, so my only chance is that I need to use the relative velocity equation for general plane motion. So that would be this. Okay, this will be my equation which I'm going to use. I need to find VC. So VC will be equals to VB plus omega into RCB. First of all, before moving forward, we're going to move step by step. Before moving forward, do you understand till this step or not? If there is anything not clear, please ask. I'm just explaining the logic. which we are using to solve the problem. Okay, so now we need to find VC, but VC is equals to VB plus omega CB. Um, may you please repeat? Okay. Okay. The thing is that, once again, let me repeat once again. The thing is that we need to find what is the velocity VC. Okay. We need to find what is the velocity of the block. Now the block is connected to the link CB. If we find what is the velocity of point C on the link CB, then that velocity would be the same as the velocity of the block. Do you understand this point or not? So what we need to do is that we need to find what is the velocity of the point C on the link BC. But the link BC will not be in pure rotation or translation, rather it will be in a general plane motion where you will have rotation and the translation both. So now we have to use the equation for the general plane motion, and the equation for the general plane motion here is VC is equals to VB plus omega into RCB. Is this thing clear or not? Okay. So let's move step by step. Omega CB. Omega CB is means the omega for this link CB. Okay, is this thing given to us or not? So this thing is not given to us actually. What do we have? We have omega AB, but we don't have omega CB. So we don't have this thing. Okay. Okay. Now let's see one thing. Look at the point B. Now, point B is basically uh, point B is a common point for the link BC as well as for the link AB. Now, I don't have the velocity of point B, but I can determine the velocity of the point B by using the link AB, because I know what is the angular velocity of the link AB. I know what is the angular velocity of the link AB, and I know what is the radius. So I can find what is the velocity of point B. And this velocity of point B will be the same as the velocity of point B when it is in link CB, because the point B is the common point between BC and AB. Yes, the connecting point have the same velocity. Okay, so this is the idea that we are going to use here. So look here, VB is equals to R omega AB. Omega AB is given, and R we know radius for the link AB. So we're going to find what is VB, and VB we have already determined. Before moving forward, first of all, do you understand how did we determine VB or not? Okay. Is there anyone who do not understand how did we get VB? You can ask. Okay, now have a look here. Now this is our main equation that we need to find out VC, but at least now we know VB. Okay, but remember VB is a vector quantity. Here when we multiply R with omega AB, we got the magnitude. We didn't get the direction. Okay, so but we can get the direction in reality. How we can get the direction? Look here very carefully. Okay, now you need to look here carefully. Yes, Matt. is VA equals to VB? Once again, uh, okay. Look here. When you say VA means this point, velocity at this point. Okay, but this velocity at this point will be zero. This is a fixed point, right? This is a pin connection to a support. So VA will not be equal to VB. VA will be zero. VB is having a velocity, okay, but VA will be zero. Make sense? Okay. Okay. So have a look here. We are trying to solve the problem. We are trying to solve the problem when theta is 60 degree. So when this theta is 60 degree, so what I can do is that I know that if I draw the circle, if I draw the arc, so it will be circular motion, right? It will be circular motion like this. So the motion of this B will be tangent to this arc. Okay, motion of this B will be tangent to this. This is 60 degree. This is 60 degree. Okay, if this is the 60 degree, that means this is also 60 degree. Okay, but this total is 90 degree because the motion of the velocity VB should be tangent to uh, this link. Okay, so if this total is 90 degree and from the horizontal it is 60 degree, then this should be 30 degree. Let's have a look at this thing in this figure. Okay, so look here, this is 60 degree, so this is 60 degree, but VB should be tangent to this arc. Okay, so the arc would be like this would be the circular motion. Okay, so since it is tangent to this, so tangent means it will make 90 degree from this radius. So if this is 60 degree, this is 60 degree, then this angle would be 30 degree. Okay, before moving forward, is this point clear or not? Is there anyone who do not understand this point or not? I'm finding the direction of VB. Try to understand what I'm doing. I'm trying to find the direction of VB. The direction of VB will be making an angle of 30 degree. Okay, and how do I know? Because VB should be tangent to the circular motion. And tangent means with the rod AB, it should make 90 degree. But the horizontal is making 60 degree. So the remaining is 30. If this point is clear to you, okay, so tell me one thing. VB will have component in X and Y direction. In what do you think? X positive or negative? X negative. And Y positive. Exactly. So now look here. So now look here. I say VB, this magnitude 1.2 multiplied by negative cos 30 I plus positive sine 30J. Do you understand this thing or not? I put VB in the vector format, but I have to mention that, okay, there is Y component and X component, and I have to mention that the X component is negative and the Y component is positive, and I have to mention that, okay, this is making an angle of 30 degree from the horizontal. Is this thing clear or not? Is there anyone who thinks that so far this step is not clear? You can ask. Okay, okay. So let's move forward. So now this thing is done. It is clear. Okay. Now one thing also, we see. You know this piston. Okay, this block. When the link AB is going to rotate like this, what do you think? How would be the motion of the block? First of all, the block, can the block move in x and y direction both? It cannot move in x and y direction both. It can only move in the x direction, but to the left. Okay, only in the negative x direction. So I know the, because of the diagram picture, I can imagine what will be the position, what will be the direction of motion of block C. Okay, so I can come here, and for VC, I don't know what is the magnitude of VC, but I know what is the direction, and it would be negative I. Make sense or not? Is it clear? So this thing is clear so far. This thing is also clear so far. Okay. Omega CB, I don't know. Omega CB, I don't know. Okay. This right now, I don't know what is the angular velocity of omega CB, but I know one thing, that whenever I take a cross product, now this is a vector product. This is a cross product. You studied cross product before in some subject, maybe statics. Remember, whenever you have cross product, the end result would also have uh, a specific direction. Okay, so remember one thing, that if something is rotating, the the direction of rotation, or will always be considered, or the vector direction for that thing will always be considered perpendicular, or along the axis of the direction, along the axis of rotation. So something, let's say if I have a body like this, and let's say the body is rotating like this, then the axis of rotation, that will be my direction for this vector direction for this object. Okay, so if the object was rotating, uh, let's say if the object is rotating like this, okay, along any axis, so that axis would be considered my axis of rotation. Okay, so here in this case, we know one thing. Here in this case, we know one thing, that there will be rotation in this member CB like this. So we know that the axis of rotation will be through the board, through the board. Okay, so it will be in the k direction. If I say this is x direction and that is y direction, then this will be the z direction. Okay, so if this will be the z direction, so I know that omega CB will be k. Okay. Okay, take it for granted if you do not understand, because now I have to explain you the right hand rule. Do you know the right hand rule for the vector product? You know, there is a scalar product, there is a dot product and the vector product. For the vector product, there is a right hand rule. Do you know about that right hand rule? Because if you don't know, it will be hard for me to explain you how did I mention it. But anyways, just understand this thing, that it will be in the k direction, since our whole motion is in the x and y direction. The direction for the rotation will be in the k direction. Okay, if you don't understand it right away, it is related with the right hand rule, so just take it for granted. Did you study the linear algebra yet? When you're going to study the linear algebra, there will be vector analysis, or the vector study. When you're going to study the vectors, vector analysis, then in that vector analysis you will have this thing, how to study the vector product and how to get the direction of the vector product. So right now, just take it for granted. Okay. So the omega CB will have direction K. Okay. Okay, so this thing is clear right now. This thing is also clear. That thing is also clear. Now let's discuss about RCB. Okay, again, in case of the RCB, we will have magnitude and direction. Okay, so magnitude is very clear. Magnitude is basically what? It's the length of this link CB. So it's 125 millimeter. Okay, so that will be 0.125. Is this thing clear or not? Is this thing clear or not? That's the magnitude. Okay. The next thing is the direction. Now try to focus here. RCB means the arrow will be at C and the arrow will start from B. Okay. So have a look here. If I look here, so arrow will be at C. So this will be the point where the arrow will be, and the arrow is starting at from B. So this will be the arrow. Okay. So if this is the case, can you see from the direction of the arrow, can you tell me, is the arrow in the positive x-axis, negative x-axis? Negative x, and y-axis? Positive. Okay. And remember, it is mentioned here that this right now, this member is making an angle of 45 degrees from the horizontal. Now, you might get confused in two things. So let me just clarify it. Look, this is a member, okay? And in this member, let's say it is making an angle of 70 degree from the horizontal, but this thing is moving in this direction. Okay, so when this thing is moving in this direction, so from the horizontal, maybe it is making an angle of uh, 10 degree downward from the horizontal. So these two degrees are different. One is what is the position of this angle member from the horizontal. The other is what is the direction of velocity of this point from the horizontal. This is the direction of velocity. This is the actual position, geometric position right now. So actual geometric position is different than the direction of velocity at that point. Okay, so previously when we determined that it was 30 degrees, so 30 degree was the direction of velocity, but actual member geometry is at 45 degree. Now this is a difficult point for you to understand, but I don't know whether you can visualize or understand it or not. So far, are you able to understand this point or not? The 30 degree was the direction of the velocity of member B, or of the point B. But 45 degree is the geometric position of this member CB from the horizontal. So velocity of point B could be at different angle than the actual geometric position of member CB. Is this thing clear or not? So now you can see here. So this is, so it will be negative cos 45i plus sine 45j, because we are talking about here right now the geometric position of the member. It's RCB. Okay, so it will be, that's the magnitude, and this is the direction, and it will be negative for the in the x direction, positive in the y direction. Is this thing clear so far or not? Okay. So now my whole equation is actually clear. So it's VC negative I plus 1.2 into negative cos 30I plus sine 30J plus omega CB K cross product 0.125 negative cos 45 I plus sine 45J. Okay. Now the only thing that I need to do is separate the I and J components. Separate the I and J components. Okay. So let's talk about the I component. In I component, if I will have negative VC here is equals to negative 1.2 cos 30. That will be here. This is the J component. Okay. Before moving forward, is this thing clear here or not? Negative VC equals to negative 1.0392. Is this thing clear or not? Okay. Now let's talk about the last one. Okay, here, this one. Look here. Omega CB has the direction K, but it is in cross product. It is in cross product with I. So K cross I is what? K cross I is what? Okay, did I mention it here like this? Okay, now how do you determine it? How do I do it? Is like this. I write here I J K. Okay. So I into J will give us K. K into I will give us J. So here K into I will give you J. So this is actually J. So I'm not going to use omega CB into negative cos 45. Rather, I'm going to use omega CB into sine 45. So it will be omega CB multiplied by 0.125 multiplied by sine 45. Why? Because K cross J. K cross J will give us negative I. K cross J will give us negative I. So K cross J will give us negative I. So negative I means that's why I'm going to put a negative sign here and then omega CB into 0.125 into sine 45. Is it clear or not? Okay, what did you not understand? Can you please open your mic and directly ask? Because we are almost finishing the time. The last step of the cross product, look here, we say that this is K cross J. Now it is supposed to be in the clockwise direction, but if you move in the counterclockwise direction, then you will get a negative answer. So I cross J is K cross J is negative I. So here K cross J will give you negative I. Since we are solving it for I, so that's why the negative sign come here. Then omega CB into 0.125 into sine 45. Is it clear? So now, like the way we did it for I component, in the same way we are going to do it for J component. When you're going to do it for J component, you're going to get omega CB. When you're going to have omega CB, you're going to substitute omega CB in here and you're going to get VC. So that's the solution. Is there anything in the solution which is not clear? Please ask. Is the solution of the problem clear or not? Okay. So with this problem, then you have another practice problem, self-study problem. Chapter number 16 is finished. We are done with chapter number 16. We started chapter number 16. I solved 3 problems with you in chapter number 16, and that's it. That's the end of chapter number 16. You have 6 problems with you for your own practice, 3 for self-study, 3 for practice problems, and you will also have the homework problems related to it. So anyways, that makes up the complete chapter number 16. Next week, inshallah, we're going to start chapter number 17. Okay, if anybody want to ask anything, you can ask. Otherwise, time is over and also the lecture is over. And inshallah, meet you next week.